How do solar panels work? Solar panels are made of silicon, a type of crystal or a crystalline element. Silicon is one of the most common elements on Earth. But if you just put silicon in the sunlight, it won't create any electricity. To make a solar panel, you need two types of silicon. One atom of normal silicon has 4 electrons on its outer layer, or 4 valence electrons. But phosphorus, another element, has 5 valence electrons. So when you add it to plain silicon, there are extra electrons. Electrons have a negative charge, and since there are extra electrons on this silicon, we call it N-type. N is for negative. The other silicon in solar panels is made with boron, an element with only 3 valence electrons. When you add it to plain silicon, there are missing electrons, or holes. Because it has less electrons, negatives, the positive charge outnumber the negative charge. So we call this silicon p-type. P for positive. Then you put the n-type with the p-type. When this happens, the positive charges and the negative charges along the border join together because opposites attract, and they form an electric field that makes it hard for other charges to travel. But when the sun's energy, called photons, hit the solar panel, it pushes electrons from the N-type silicon past the electric field and into the P-type silicon. These electrons want to get back to where they started. If you put a wire that connects the P-type silicon to the N-type silicon, they can move along it to get back to their side. If the photons, the sun's energy, keep hitting the solar panel, electrons will keep moving and will create a continuous stream of electrons along the wire. When electrons move in a stream, you create a current of electricity, which can be used to do things like power a light bulb or a fridge. And that's how solar panels uses the sun's energy to create electricity.